Okay, so today we're going to talk about solving radical equations a little bit more. So go ahead and jot down number 1. The square root of 2m minus 6 equals the square root of 3m minus 14. What are we going to do to both sides of the equation? Square it. So when I square it, I'm just left with what's inside. So this is 2m minus 6 equals 3m minus 14. What am I going to do now? Okay, get everything isolated. So I could subtract 2m. I get just m here. Add 14. I'm going to get 8. Am I done? Good. You must check it. So I want to know if the square root of 16 minus 6 is equal to the square root of 24 minus 14. Well, that gives us the square root of 10 is equal to the square root of 10. Is that true? Yeah. You have to make sure you're taking the time to check these.
What if that's not true?
Then what would your answer be? No solution. So if that is not true, it would be no solution. All right, look at number 2. The fifth root of x plus 4 equals the fifth root of 3x minus 2. Now, just because we've got fifth roots this time instead of square roots, nothing changes. What are we going to do to both sides? Yeah, raise both sides to the fifth power. So we're left with what's inside. X plus 4 equals 3x minus 2. So I get 6 equals 2x. And what does x equal? 3. Now I know we kind of stressed that if it was an odd root, you don't have to check because you're not going to have extraneous solutions. I would recommend on these more complicated problems when you've got x's on both sides, whether you've got an even root or an odd root, to go ahead and double check your work. Okay? It's a really good habit. There's a lot of places to make mistakes, as you'll see as these problems get more and more complicated. So it takes just a few seconds. Go ahead and plug it back in. I would have the fifth root of 7, and is that equal to the fifth root of 7? Yeah, so that would be my answer. Alrighty, take a look at number 3. 4 times the square root of x plus 1 equals 3 times the square root of x plus 2. We've got radicals on both sides. They have coefficients, but that's okay. We're still going to go ahead and square both sides. And make sure you think about what happens when you square both sides. This 4 ends up getting squared as well. So 4 squared is 16. And then when I square the square root of x plus 1, I would have x plus 1. Make sure you remember your parentheses. This is 4 times the square root of x plus 1, which is why you can and have to distribute your 2. Okay, same thing over here. What are we going to end up with on the right side? Good. What would we do next? Distribute. So I would have 16x plus 16 equals 9x plus 18. If I subtracted 9x from both sides, I would get 7x equals 2. So x equals, now, you cannot decide, I don't want to check this one. I don't like how that number looks. Okay? You can't just bail on checking your answer just because you don't like that you got a fraction. You still need to check. Okay? So let's check. I want 4 times the square root. If I have 2/7 plus 1, that would be 9/7. I don't know if that's equal to 3 times the square root of 2/7 plus 2, 16/7. All right, ideas on how to figure out if those are equal. Can't if you're on your test or your quiz with no calculator. Huh? Okay, you could try and get the 4 and the 3 back under the square root and make sure they're the same. Okay. Could you square both sides? Yeah. Could you simplify your square roots? Yeah, so any way you decide to go about it is fine. Okay, this would be the square root of 9 over the square root of 7. So what's the square root of 9? 3, so we would end up with 4 times 3 over the square root of 7. And over here I would get 3 times 4 over the square root of 7. Are those the same? Yeah, because it's 12 over root 7 equals 12 over root 7. Okay? All right, we're going to skip the number 4 that is written here. And let's go to number 5. The square root of 4y plus 1 minus the square root of y minus 2 equals 3. Okay. Do they have the exact same radicand? No. Okay, you can only add and subtract radicals if they have the exact same index and the exact same radicand. So what we're going to do here is go ahead and move one of your square roots to the other side. So I would get them positive to make our life at least a little bit easier. It's going to be easier if you square it over on this side. Okay, now from here you are going to square both sides, and you've got to pay really close attention to what you're doing. Okay, well, the left side's easy. When we square the square root of 4y plus 1, what do we get? Good. The right side, however, you have two things being added. So what are you going to have to do? You're going to have to double distribute. So this is going to be the square root of y minus 2 plus 3 times the square root of y minus 2 plus 3. This is an addition here. You cannot distribute that squared. All right. So we're going to have 4y plus 1 equals, what's the square root of y minus 2 times the square root of y minus 2? Good. And then I'm going to have 3 times the square root of y minus 2 plus 3 times the square root of y minus 2. All right, and then 3 times 3 is 9. Everyone okay there? All right. So we still have a radical in there that we're going to have to deal with. So we need to isolate that radical now. So get your y's and your constants over to the left. You can combine the negative 2 and 9 on this step, or when you just move everything over, you can do it in that step. Okay, so I've got y over here, so I'm going to subtract y, so I'm going to get 3y. Negative 2 plus 9 is 7. If I subtract 7, minus 6. While you are allowed to divide by 6 here, you're going to end up with a fraction on the left. And I know your love for fractions is not super strong. So in that case, go ahead and leave it over here for now. But now we do want to get rid of that radical. So what are we going to do? Square both sides. So if you need to write out 3y minus 6 times 3y minus 6 in order to visualize it, please go ahead and do that. Okay? 3y squared is going to be 9y squared. Then we would get minus 18y minus 18y, which gives us minus 36y plus 36. is equal to what? 36 times y minus 2. Okay, what would we do next? You can, but you're going to end up with a fraction up here. Yeah, let's distribute. So 9y squared minus 36y plus 36 equals 36y minus 72. This is a quadratic now, and a quadratic has to be set equal to 0 in order to solve. So get your, oh, sorry, I forgot my y right here. So we've got to move everything over to this side. So I'm going to have 9y squared. If I subtract 36y, I'm going to have minus 72y. And then when I add 72, I'm going to get plus 108. All right, what's the easiest way we know to solve a quadratic? Factoring. So if we want to factor this, what do I need to take out first? The 9, which is our GCF. I get y squared minus 8y plus 12.
In this case, do you even have to worry about that 9? Does it like goes away?
No. All right, how we need factors of positive 12 that add up to negative 8. All right, so I'd have y minus 6 and y minus 2. So my possible solutions at this point, does that 9 give me a possible solution? No, because 9 is never equal to 0. What possible solution do I get from y minus 6? Y equals 6. And what about y minus 2? Good. What do we need to do now? Check it. So take a sec and check both of those answers. What do you notice? They both work. Okay, I understand it's a really long process, but tell me, are there any steps that you weren't sure about?
If we were to do it though and get a fraction, would it get really complicated?
What do you mean?
Like, you know, in the steps where like you could divide by like 30 or you know like whatever 9 or whatever number it was here, but you didn't end up with a bunch of fractions. So if we get a bunch of fractions, should we just like try and do an alternative way?
I would. Yeah. All right, let's try number 6. The square root of 4x plus 1 equals 3 plus the square root of 4x minus 2. Okay, so what would we do first? Square both sides. So I get 4x plus 1 equals 3 plus the square root of 4x minus 2 times 3 plus the square root of 4x minus 2. So 4x plus 1 equals 3 times 3 is 9. I have 3 times my radical plus 3 times my radical, so that's 6 times my radical. And then what's the square root of 4x minus 2 times the square root of 4x minus 2? Yeah. Okay, what would we do now? Yeah, get our radical by itself. So if I subtract 4x from both sides, those end up canceling, right? So I have 1, and then I've got 9 minus 2, which is 7. So if I subtract 7, I get negative 6 equals 6 times the square root of 4x minus 2. Okay, if we divided, we'd get negative 1 equals the square root of 4x minus 2. What do you notice?
Well, the square root of something equals 1.
Yeah, our square root is equal to a negative. Can our square root ever be equal to a negative? No. Your square root can't be equal to a negative. So our answer here is no solution.
If we were to keep solving it out and we got our answers, we'd plug it back in with neither one of them.
Probably.
Okay.
But you'd like to save yourself the time and the energy and check it out earlier. Okay. Please copy down number 8. 2x minus 1 to the 1/3 power equals x plus 1 to the 1/6 power. I would recommend not turning these into radicals. Okay? Think about it. We want to get rid of these fractional exponents, right? That's what radicals are. They're fraction exponents. What could I raise both sides to get rid of the fractions in my exponents?
6.
Yeah. If I raised both sides to the 6th power, think about what you do with your exponents. What is 1/3 times 6? 2. So on the left, I end up with 2x minus 1 squared. On the right, what's 1/6 times 6? 1. So I just end up with x plus 1. So have we successfully gotten rid of our radicals? Yeah. Questions? All right. So we need to do 2x minus 1 squared. So make sure you're double distributing either on paper or in your head. 2x squared would be 4x squared. Then we'd get minus 2x minus 2x. So minus 4x plus 1 equals x plus 1. All right, subtract, and we get 4x squared minus 5x, and then our 1's cancel. Okay, a lot of people hit a brain freeze at this point. Okay? Don't hit a brain freeze here. It's actually really, really easy. Remember that your first step in dealing with a quadratic is always to look for a GCF. What's our GCF here? Okay. So we have x times 4x minus 5 is equal to 0. Well, guys, this now is factored. We have two things being multiplied together. So we take each factor and set it equal to 0. So we get that x equals 0. And then what about from that one? 4x minus 5 equals 0. So what does x equal? 5/4. All right, let's go ahead and check these. If I plug in 0, I'm going to have 0 minus 1 is negative 1 to the 1/3 power. And I want to know if that's equal to 0 plus 1 is 1 to the 1/6 power. Are those going to be the same? No, why not? Yeah, one's going to be negative 1, the other's going to be positive 1. So 0 is an extraneous solution. All right, let's look at 5/4. 2 times 5/4 is 10/4 minus 1. I'm going to write it as 4/4 to the 1/3. So that would be 6/4, which is 3/2 to the 1/3 power. Checking our answer? Huh? Okay. All right, let's plug it in on the other side. 5/4 plus 4/4 to the 1/6 power. That would be 9/4 to the 1/6 power. Okay. We got to see if these are the same. Right now it's kind of hard to tell. But what you could do is you could raise both sides to the 6th again. Or would you agree that this is the same as 9/4 to the 1/2 power raised to the 1/3 power? Do you agree with that? And what's 9/4 to the 1/2 power? Yeah, that's the square root. So it's 3/2 to the 1/3 power. Do those match? Yep. 5/4 is your answer. Questions on that one? All right, let's look at number 9. Okay, we've got 3x plus 2 to the 1/2 power equals 8 times 3x plus 2 to the negative 1/2 power. Okay, what does that negative 1/2 power do? Makes what go where?
1/3.
Okay, so the base is going to go to the denominator. So this is going to be 3x plus 2 to the 1/2. Where does the 8 go? Stays on top. Good. Why does the 8 stay on top? Good. It is not part of your base. Okay. All right, now what would we do?
Square them.
Okay. I'm sorry? Yeah, there's other methods to solve this. You can apply with the fact that these have the same base, and you could deal with it that way. You just need to figure out how. Okay. So when I square this side, what am I going to end up with? Okay, what do I do with this squared? Yeah, 64 over 3x plus 2.
Oh, so like, did it and be like 3x plus 2 squared over 8.
Okay, what would we do next? Multiply by this 3x plus 2. All right, so go ahead and double distribute. I have 9x squared plus 6x plus 6x, that's plus 12x plus 4 equals 64. What would I do next? All right, so I would have 9x squared plus 12x minus 60 equals 0. What would you do next? Okay, and what's your GCF?
3.
So 3 times, well, it's 4 minus 64. So it gives us minus 60. So this is 3x squared plus 4x minus 20 equals 0. All right, now we need to factor. So our a value is not 1, so you've got to do a few more steps when factoring this. So 3 times negative 20. So I need factors of negative 60 that add up to positive 4. Good. Negative 6 and 10. So this is 3 times 3x squared minus 6x plus 10x minus 20. All right, pull out the GCF of the two groups. So I have 3x times x minus 2 plus 10 times x minus 2. My insides match, which is awesome. So I have 3 times 3x plus 10 times x minus 2. All right, so what are our possible solutions? X equals negative 10 thirds and x equals 2. All right, let's check it. If I plug in negative 10 thirds, well, negative 10 thirds times 3 would just be negative 10, plus 2 is negative 8. So the 1/2 power. Okay, right there, what do I know? Yeah, you can't do that. So can you keep going on the negative 10 thirds? No. All right, let's try 2. 3 times 2, 6 plus 2. So this is 8 to the 1/2. And I want to know if that's equal to 8 over what? 8 to the 1/2. Or wait, sorry, let me do it from the original equation. This would be 8 times 8 to the negative 1/2. Well, what power is right here? It's 1. So what can I do with my 1 and my negative 1/2? Add them. So you get 8 to the 1/2 equals what? What's 1 minus 1/2? 8 to the 1/2. They work. So 2 is your only solution here. Alrighty. We're going to skip that 10 and look at number 11. All right. What would we have to do here? We're going to have to square everything. Yeah? It's not going to be pretty, but we can handle it. Because when you square this, can you just say that's k plus 9 minus k? Nope. You have to double distribute. Don't whine. What do you mean?
I don't understand exactly what we're doing this for. Like, does this lead up to something? Like, are we going to use this equation? Or, like, what do we need this for? Like, what's a real world situation?
We're going to get to some application problems later as the unit goes on. But, I mean, basically right now you are gaining comfort solving radical equations. And in order to make sure you're really comfortable, you have to work the challenging ones as well. Okay? The square root of k plus 9 times the square root of k plus 9. K plus 9. Okay, then I've got the square root of k plus 9 times negative root k. That would be minus the square root. You could either write it as k times k plus 9, or you can go ahead and distribute k squared plus 9k. It's totally up to you.
Did you for any reason put the negative 30
Good. All right, then we have that again, right? And then minus root k times minus root k plus k equals what? 3. All right, so k and k, so I have 2k plus 9. And then would you agree I could write this as minus 2 times the square root of k times k plus 9? So this is like minus 1, minus 1. All right, get everything over to the other side. So I have negative 2 root k times k plus 9. There's an addition in there. Because I need to isolate this other radical so that we can square it again. So this would be, I subtract 9, and I subtract 2k, so I'm going to get minus 2k minus 6. Now in this case, would it make sense to go and divide by negative 2? Yeah, because it divides evenly into everything, right? So I have the square root of k times k plus 9 equals k plus 3. All right, what do we do now? Square it. I never said it was quick and easy. So I get k times k plus 9 equals k squared plus 6k plus 9. So we get k squared plus 9k equals k squared plus 6k plus 9. What do you notice? Your k squareds cancel. Can I subtract 6k? So I have 3k equals 9. So k equals 3. I will go ahead and tell you that if you check it, it works. Question, yes. Quiet, please.
Would it have been easier if you had changed the negative root k, like added root k on both sides?
That's totally an option, yes. And yeah, that might have been a lot easier. Okay? All right, we're going to go ahead and skip that last one. I'll pass out your homework. Real quick, though, before I stop this, too, for anyone who's not here. You might notice on the calendar that your quiz has gotten moved to Friday. Okay? But that does not mean that the material on the quiz has changed. The material on the quiz is still 6.1 through 6.4. So today is the last day of notes for the quiz. What we learn tomorrow, 6.5, will not be on your quiz. Okay?